So I'm now recording this. This is like assessment 3 review. And the README here, we're talking about the book publisher database. And we've just reviewed the schema. And now we're going to basically walk through how we would get from here to a Dockerized database that we can push up to our Docker Hub account and other people can pull down and use. So to do that, we're going to kind of take it piecemeal, and we're going to start by using a disposable Postgres database, and we'll make sure that everything works. And once it works, then we'll package all up and, with a bow on it. Okay. So I'm going to grab this, and I'm going to paste this in my terminal. So this is just a simple command, which will be good enough for us. And we're going to do Docker run. We can give this a name. This is an optional flag. We don't have to do this. For this particular container, this is a requirement. You have to give it an environment variable, which is the Postgres password. That's just what this container is expecting. It's how it's set up. So every container can be a little bit different. It might have additional environment variable requirements, might have none. And then this -d flag is to run in detached or daemon mode, which just means it's going to run in the background, so it's not going to take up your terminal. And then here is the actual image name. So the basic command, the kind of bare command, is Docker run Postgres. And all of this other stuff is additional configuration and information. Okay, so if I run this now, if I press enter and execute this command, it's going to pull down a Docker image if I don't already have it cached locally, and then it's going to start running. But it's going to be running as an isolated process, and I won't be able to directly connect to it. So what we want to do is want to be able to connect from our local machine into this container. So how do we create a mapping or a connection from the host machine to the container?
Using -p.
Yeah, exactly. So Postgres is a server. So the architecture of Postgres is a client-server application, which means that when you use a tool like PSQL and you submit queries, you're basically, you have a client, which is kind of like, like your browser or curl or whatever, and you make an HTTP request to this server, which is listening on a specific port, and it takes that request in and processes it, and then returns you a result. So because it's listening on a specific port, we have to use port mapping. So -p, and we can choose basically an arbitrary port. Yes, is there a question? Okay, so I'll just choose I'll do 5454. That's an arbitrary port on my host machine, and I'm going to map that post or that port to something on the host machine. And Postgres by default will run on 5432. So I'm going to go ahead and run this now. So it's going to pull this down, and it should start running it. And I'm gonna use dbeaver to make my life easier. Okay, well that opens. I'm gonna make sure that this is actually running. So Docker PS, and that is running. I can see that it's running. It's got the name that I gave it, which is some Postgres, which comes from right here. This is not necessary. If you don't provide this, it'll just give you a made up name. And then we see here that what the port mapping is. So from the host machine 5454 is going to map to 5432 on the container. So I'm going to delete this connection and start new. Okay, so to create a connection to this database that I have running, I'm going to choose this right here, new database connection. It's a Postgres. And then I provide the specific information here. So localhost, that's fine. The database is Postgres. This is just the default Postgres. I'm going to have to change this because this dbeaver application is running on the host machine. So it needs to access through 5454. And then the password I have to provide it is whatever I passed in as the environment variable. So I'm going to grab that. Okay, and then I'm going to test the connection to make sure I got all that right. Okay, if that's not working, you have to debug that, but this is working. So now I have this connection to the Postgres container. So I'm going to create a new script. And now what I can do is I can start executing SQL queries. So the first thing I'm going to do is I'm going to start creating tables. So are there any restrictions I need to think about when I start creating tables?
You can't start with tables that have dependencies. So you could start with author, book, or genre in this case.
Yeah, exactly. So if we look at, the relationships between all these tables, you can see that author can exist independently, right? You can have authors and it doesn't need anything else. Genre also exists independently, book also exists independently. But these two join tables don't make any sense unless you have a book and an author or a book and a genre. So there are ways to do that without worrying about the order, but then you create the tables and then you have update statements at the end that create all the primary key connections. But we'll do that all in a piece. All right. So I'm actually going to go save myself a little bit of trouble here. I'm going to copy the SQL statements. Okay, so the first table we're going to create is book. So the statement create table book, and then we're going to give it a primary key. So what are we doing on this line? What is ID serial primary key?
It'll be an ID that is associated with every book that you put into it, and it's just a one-up number.
Yes, exactly. So it's an auto incrementing integer. So anytime you create a new entry, a new row in the book table, Postgres will automatically handle making sure that you have a unique ID. Okay, so if I execute this, I get some feedback. Basically, there's no error. So I can assume that this table exists. I can confirm that by writing a query. So select star from book. Okay, and I see that I have the table successfully created. There's nothing in it, but this works. Okay, so the next table I can do, we have book. We could have started with author or genre, but I'll just do these two as well. I can run these. and I don't get any errors. So we could do the same thing, select star from author, select star from genre. Now, if I try to rerun these again, what's going to happen?
It'll error out because you already have tables with those names.
Yeah, exactly. So it's going to tell me that the table is already there. So book already exists, author already exists, genre already exists. So as you're developing as a convenience, you can do a couple things. So you can add like drop table if exists. You obviously don't want to do that, in production or whatever, but as you're developing, it's a convenience because you're probably going to be creating a table and then changing it and then, adding some test data and then deleting it and trying to add more, etc. So you can either add those statements there, or you can have a separate line, a separate section basically up here. So we can do drop table if exists book. We'll do the same thing. Drop table if exists author. So now I can execute these, and I shouldn't have any tables, and I should be able to execute this whole block over and over and over again. So this will basically reset all of my tables. Okay, any questions about that?
I actually do have a question about, so as we were going through some of the challenges, we didn't have to do the drop table if exists when we were creating the init files. Is that because that initializing file will only run once as you're building that container image and it's no longer a run?
Exactly, yeah. So the
Okay.
init is basically a one-time thing. It's a script that runs once. So you can, you run it and you create the database, all the tables, and then all of the rows in those tables in that database, and it's just meant to be there. If you want to like start over, you can just delete the container and create a new container for the new script. But yeah.
Okay, got it. Thanks.
And that's what you'll do once you go through this process, the piecemeal kind of more local development. Once you're sure everything works, then you throw in the script. Should work hopefully. Okay, so I'm gonna do these other tables. Okay, so we have book authors, and same basic thing. The only difference is now we have this. So what is this called? This is a primary key. What are these?
Foreign keys?
Yeah, exactly. So foreign keys. So it's foreign because it connects to a table that's not itself. So that means that if we want to run this statement, then the book table has to already exist, and the author table has to already exist. And same here, book and genre. Okay, so now if I try to run this entire script, that works fine. And if I try to run it again, now I get an error. An error is telling me that it can't drop the book table. So it can't drop this first table because other objects depend on it. So what depends on book table? You can see constraint book authors dash book ID, which is book authors, book ID, blah, blah, blah. So what would happen if, Postgres didn't throw this error? So if I tried, let's say I had all these tables, they existed, book, author, genre, etc. But now I delete the book table. So book doesn't exist anymore.
You'd have two tables that depended on something that doesn't exist.
Yeah, exactly. So you have now book authors still exist, and it has a book ID, which is a reference to a table that doesn't exist. So it's kind of like, what does that mean? Can you can't really do anything with that. So there are a couple options for handling that. The simplest one is just to make sure that if you drop a table, you also drop any other tables that depend on that. So you can do drop table if it exists. And then we can actually throw a cascade keyword here. So this will cascade, it will like follow through and delete any other dependent tables.
So Cascade, it deletes the dependent tables, or does it delete like the dependent ID out of that table?
It should delete the table itself. So you could try that. So let's see if book exists, for example. So I'm going to do select book. Might not be a good example since we don't have any actual data loaded. But you can see that this table exists, and then book authors do the same thing. Okay, so we have both of these tables. So now if I execute this statement, the drop book cascade, if I try to select from book authors, it does exist. Okay. Yeah, so it looks like it will maybe just remove the primary key or that constraint. Actually, go in here. Okay. Yeah, I could play around with that later. All right, for now.
So maybe it just removes like the foreign key from book authors then?
Yeah, let me try creating this one more time, and I'm going to create these tables. Yeah, this menu on is not sure why. Let me refresh this. There we go. So you can see here that you have author, book authors, book genres, genre, etc. So if I now delete this, let me refresh this. And we don't have book, but we do still have book authors. Yeah, it might just delete the associated data. Yeah, to be honest, this is really only something that I use in like development. So you wouldn't necessarily want to do this in like a production database. So. Okay. All right, so we have our schema with all the tables created, and it appears to be working. Go ahead and do this one more time to make sure the whole script runs. And then we could add some data here. So a few ways to get the data. One, you could just, write a few lines by hand. You could go to like you could probably use ChatGPT for something like this. Generate some dummy data. There's also Makaru, which you guys saw, so you can, provide some constraints and it'll generate random data within those constraints. So I'm just gonna copy all this for now. Minute. Okay. So today I just run the whole thing as a script. So book ID 19 is not present in the whole book. Let's see. So I'm getting an error. So insert update on table book genres. And it's trying to insert book ID of 19, which is right here. So let me just delete this last line. I'm not sure what the issue is there. So it looks like it should have a book ID of 19. See if I can rerun this.
Because you need the semicolon, because it's the last of the,
It should be, maybe I am missing a semicolon somewhere else.
oh, actually, I didn't see, yeah.
Huh. Let me just try doing this one section at a time. Okay. Okay, I added the books, that works. You can add all the authors. And add all the genres. And let's try book authors. That works. And then let me just try a few of these. That works. Yeah. But I won't yeah, there's something wrong with at least a couple values in the script, but I don't want to waste time figuring what that is right now. Not quite sure. But in either case, we should have enough information to write some queries at this point. So looking back at the diagram, for example, so if we wanted to get all the sci-fi authors, How would we write that query? Well, like a sanity check, we can just create individual tables and make sure that stuff exists. So I'm gonna do select star, oops, from genre. And you can see this table exists and there is a sci-fi value in there. Okay, so we know that sci-fi exists. So how can we get all the authors who have written sci-fi books?
Start with, really you just gotta join, looks like you gotta join quite a few. So I'd start select all authors, join with book authors on, ID and author ID.
Okay,
Join-
great. We'll just do it one at a time. But yeah, so that's idea. It's pretty, mechanical process. So select star from author. So it'll automatically give you an alias. That's fine. Join, and then book authors. What's the join key on author dot ID equals book authors dot book ID. So this tool will automatically alias a table, and you can do that or not. It's up to you. So book authors B, you could then refer to this as just B. So either way is fine. You can either fully specify it or provide an alias. And once we have author and book authors, we just follow the chain. So book authors to book. We're just going to add another join book on, and now we're going to do book authors dot author ID equals author dot or sorry, book ID. And then we just move on to the next one. So book to book genres. Join genres on book genres dot genre ID plus book ID equals book ID. You just double check that. We're going to join book to book genres. So book genres, book ID equals book ID. Then the last table we have to join. So join genre on. So the order here doesn't matter. You could do genre.id equals or book genres dot book ID. So the order for the on doesn't matter. We'll do genre.id equals book genres dot genre ID. See what we get. So we have an error here. So book authors dot author ID invalid reference. Yeah, so I'll get rid of this alias right here. Yeah, so the error was from using an alias some of the time and sometimes not. So you can pick one, but you can see all of these authors, and let's see. So now we have all of them, right? We have all of basically all of the authors and the genres, but we just want the sci-fi. How can we limit the genre to just sci-fi?
That would be where type equals sci-fi, and sci-fi would have to be in single text.
Yep. Okay. So where this is the filter, like the filter clause, and we could do type, and we could probably get away with just doing type because no other tables here have a column called type.
Yeah. Well, it looks like it's a reserved word though, so I think we
Yeah.
have to do genre.type.
Yeah, so this is a reserved word. So there's a couple ways to handle that. One is you can just let it go. So we'll do this first, where type equals sci-fi. Okay, and here are just the authors that have sci-fi novels. You could also, this is what quotes are for, the double quotes. So if you have basically an irregular column, this also works fine. So you're basically indicating, hey, this is not the the keyword type, but Postgres will basically automatically take care of that for you. But this is a way to make that explicit, that you're not referring to the reserved word. And you could also do, instead of just type, which works in this case because there are no other ambiguous column references, but you could be more specific and say genre dot type. Actually give us the same result in this case. But if, for example, author had a column called type, then you wouldn't just be able to use type by itself. You'd have to specify. Okay. All right. So any questions about that? Okay. So once we're happy with, we're sure everything works locally, we have everything worked out, then we want to basically transplant this into the final version, which will just basically run this in an automated way. So you can look at the model here, for example. So all of the database examples follow this, and for the assessment, you'll do the same thing.
I have a quick question.
Yeah.
So when you were joining the first three tables, I think you joined them on the wrong IDs. You just mixed up book and author, but it still gave results. So is there a good way to verify?
Oh, that's a good question. Let me just see this real quick.
Working.
So author ID is, oh yeah, right here. So this, yeah, you're right. So this is wrong, but why didn't this throw an error, for example?
I assume just because it happens to have IDs that are the same value.
Yeah, exactly. So it didn't throw an error because like the types work and everything are just, it's all integers. So let me look back at the right here. So the mistake was author ID, book authors dot book ID, whereas this should be book authors dot author ID. So we could do, yeah, it happens. I'm trying to think of an example which wouldn't work, but this just has integer columns. Yeah, so that's a good point. I don't know that there's an automated way to make sure that you don't make that kind of mistake.
When people are building databases, do they like keep that in mind so that they don't end up in situations? I mean, I'm thinking like using different IDs of some variety. I'm not sure how to really phrase it, but
Yeah, so you can definitely write, you can write tests for stuff like this, where you would have a date, or specifically if you're using like an application, like which we'll see later. So using like a Python wrapper, and you can write unit tests in Python. Okay, I have I have the database, and I'm going to insert some data, and here's the result that I expect. So if you did something like that, basic unit testing should pick up an issue like that, but it's it's possible that even depending on how you wrote your unit tests, that it wouldn't pick up on that exactly. Let's see. So there's 14 rows. So if I go back here, yeah, I get 7 rows. Yeah, that's a great question. So yeah, I'm not sure that there would be like an easy way to do that. So another way, the one reason to test it, to write like basically unit tests and to use small data inputs, is that because here we have a whole bunch of stuff, I can't just look at it and know what the correct answer should be. But if I just had 1 or 2 authors, 1 or 2 books, etc., it would be easier. Okay, I know exactly what this result should be ahead of time. Okay. All right. So let's try and package this up now. So I'm going to go look at the example of the model, and I'll create a new repo. And I'm just going to follow the pattern that's in the example. So I'm going to need a Docker file, and init.sql, and setup.sh. So I'll create a Docker file. Okay, so the Docker file, you should just be able to basically use this as is. So before, when I'm running this, I just went to Docker Hub and I just ran a default image of Postgres, and that's fine. It's just, it's just meant to be a short-lived thing. But if you use a Docker file, you need to specify the exact image. And we also we're eventually going to copy over the script, because everything we've just been writing in dbeaver, we want to put that into a script. So it's hard coded and checked in, and we can get consistent results every time we create a container. So I'm going to copy this. And all we're doing here is saying we want to use Postgres version 15. So that's the container we want to use. We could use something else if we need a different version of Postgres, or we also need to install some other stuff or do some additional setup. In this case, it's pretty straightforward. We're just going to use this base image, and then we're going to copy whatever we write here in this init into this on the container. So the Postgres image, the Docker official Postgres image, will do some magic, and it will basically run any scripts that you put in this directory. So it's called Docker entry point init db.d. So this is a directory, and it just happens to be the case that the base Postgres image is set up to run all the scripts that are in this directory. So any script that you put, anything basically, if you actually look at the Docker file, I think it will run .sh scripts or .sql scripts. Anything you put in here, it will just run when the container is initialized. So when you run the container, it'll execute these scripts. Okay, the init .sh, or sorry, it's init.sql. Okay. Again, I'm going to look at this as an example. And in this case, it's, we're going to create a database. Before we were just using the default Postgres database, which is fine for development, but now we want to be a little more specific. So I'm going to copy this line in there. And the database that we want to have, I think it actually is called books, but you would change the name depending on what you're doing. And I'm going to grab all of the setup, so table creation and the insert statements. And I can copy that and drop it in here. And because this is only going to get run once, I can remove these little development helper things. And hopefully, if we did everything right, this should just work. And if it doesn't, we'll have to debug and go back to using dbeaver or some other tool, make tweaks, and then try it again here. Okay, so we have the init.sql, and now we have this setup.sh script, which is, again, just a convenience. You could run all these commands, individually by hand. But this will make everyone's life easier. So we're going to build this image, and we're going to give it a name, which could be whatever you want it to be. So this will be the name of the image that we build. BooksDB makes sense, but whatever application you're doing. Then we're going to run the image. So we're going to build BooksDB and then run BooksDB. And how are we going to run it? Well, we're giving it a name, which is handy later on, but you don't have to. And then we're also going to add this -rm flag, which you don't have to add. So it's just going to, when the container stops running, it'll automatically delete that instance. And we have to pass in an environment variable. We can call this whatever we want. Later on in the course, we'll learn how to basically hide credentials like this. But for now, it's fine. And we'll run it in detached mode. Then this is just kind of a hacky solution. There are more sophisticated ways. So the problem here is that we're going to run the container, but it's going to take like a second or two to spin up the process and execute the scripts and everything. And then, so we're just going to wait. There are more sophisticated ways where you could like poll to make sure that the container is actually ready. But that's a little more work. So just to keep it simple, we'll sleep for 3 seconds, and then we're going to run Docker exec. So Docker exec is just a way to run a one-off command inside of a running container. So the command we're going to run, we're going to exec into this the instance which is running, which we called pgdb, and here's the command we're going to execute. PSQL, which is the command line tool for Postgres. It's the Postgres client, and we're going to basically connect to the database, which is called books. And this books right here, this -d flag is different than this one, right? This is a PSQL command. So this -d means database. And we're going to connect to, excuse me, we're going to connect to the books database. And as long as that's the same name as this, you should be fine. So here's the name of the database. We called this database books here, so that should be fine. All right, so what's going to happen, hopefully, if everything works right, is that I'm going to run this setup.sh script. It's going to build the image that I have defined here in this Docker file. And once that image is built, it's going to actually run. It's going to create an instance of the image, the container, and this container will run. It's got to do a little bit of setup, so we're going to wait just a couple seconds for that to finish. And then we're going to execute a command here, which is just going to connect us to the database so that we can write queries, basically. So you don't have to do this. You could just, run it and then go in yourself and do this, or use even a tool. So we could use another tool to do that, like dbeaver. But for now, we'll just do it this way. Okay. So what's going to happen if I try to run this setup.sh script?
It'll build the image, then run it, and then it'll bring up like a Postgres command line that you can use.
Yeah, exactly. So if we run it and it's successful, if we're allowed to run the script, then that's what it will do. But when you create a script file, by default, you're not going to be allowed to run it. So if I try to do /setup.sh, it's going to tell me that I have permission denied. So how can I see what permissions this file has? When we do that, you can do ls-l, and it will list all of the files and folders you have in this directory. And right here, it's going to tell you what permissions these files have. So setup.sh has read write permissions. So these are three different, I forget exactly, it's three different kinds of users, but nobody has execute permission. So what I'm going to do is I'm going to modify that. There's a couple ways to do this. So chmod, I'll do 755. There are other ways to do that. I need to pass the script. And now if I run the ls-l command again, I can see that I basically gave everyone, which is not the most secure thing, but I gave everyone execute permission. So this is now a file that people are allowed to run. So I can execute the script. So it's building the file, or sorry, building the image.
Those permissions wouldn't reflect on whoever is pulling this container in the future, right? Is this just something we have to deal with locally?
Yes, yeah. If you once you set those permissions, anyone who, if someone else cloned down this repo, that file should have the same permissions on it. Okay, so it looks like it worked. So the image got built, it ran it, it waited a couple seconds, and then it ran this command, and now I'm connected to the PSQL client inside of this container. So I should be able to run, and you can see it starts with books. So I'm connected to the books database. So I should be able to run some, say, -d, and I can see all of the relations or tables that I have here. Author, you don't have to worry about these. This is the primary key, the auto incrementing primary key. So you get the -seq, and it's a sequence type. So this, internal Postgres stuff you don't need to worry about, but it's got author, book authors, etc. We should be able to run. Well, I'll just keep it simple for now. So select star from author, and I get a result. So I do some initial testing and make sure everything works. So I'm going to exit out of this. And then if we look at the books database, so the cars database README, which is what everything else is based on, will also tell you, for example, how you can run a script. So we'll take that query and we're going to put it in a file called scripts.sql. You can call it whatever you want, but that's what we'll do. So I'm going to go here. So again, like we've gone through these different iterations where we built it gradually locally. We're sure it works. We try to run it in the container. Again, like it builds correctly. So we know that at least the tables are getting created. You can do some like sanity check initial queries here. And then to run, more thorough queries or, a whole script file instead of typing everything out tediously, we can add a script. So script SQL. And then in that file, I'm going to paste this query that we wrote down here. It's singular. Okay, so now I want to execute this script on the container. So I'm going to do Docker PS. So this container is currently running. I'm going to stop. Well, actually, I'll just leave it. But here's the container that we just spun up, which has the, all of the schema already built in and ready to go. So that came from right here. So we ran this. You can see the name is PGDB, the name PGDB. Now, one issue with this is that it's running on 5432. So if we wanted to use this tool to run the query, we would have to modify what command would we have to modify if we wanted to use dbeaver to query this container.
The run command, you have to add the ports into it.
Yes. Yeah, so we have to add ports. So we could do port mapping, so -P. And again, we can choose arbitrary ports. So we already have this local image running. Let's say we don't want to, we want to keep that running in case you want to use it later. We could just choose a different port. So 5444, let's just say. So I'm going to stop this container real quick. So Docker stop 17. And if I do Docker PS, that's no longer running. So I'm going to map this 5444 to 5432. All right, so now I'm going to run this script again, set up the sh. I'm going to comment out this line. We will need those immediately. So Docker set up that sh. It's going to run. Everything's cached, so it should be pretty quick. Good. And I can do Docker PS. And I can see that this is now running, but I have the ports mapped. So I'm going to go over into dbeaver, and I'm going to create a new connection to this other database. And this time it's going to be 5444. Let me check the password. Just password. And the database is no longer going to be Postgres, it's going to be books. I'm going to test the connection. That works. So now I finish this. I should be able to go. Here's a script. So I'm going to copy this and I'm going to try to run it. Okay. So that works. yeah, I can verify the query, but the query basically works. So we could verify the data and everything, but I executed this query on this other database. So that's one way to make sure that everything's working. But we're gonna follow this for now. So I'm gonna go ahead and stop this other container. So Docker stop 6F. And I'll remove the port mapping. You could still leave it, but I'll just remove it. And this time instead of this command, we're gonna exec and we're gonna run the script file that we just made right here. So we could add that as part of the script if we just want to run that automatically. So yeah, well, we'll do it by hand for now, but you could also add that command there. I'm going to run this. Okay, and then I'm going to use this Docker exec command. If I paste this in, so I'm supplying the password as an environment variable when I run the script. Otherwise, it'll ask you for it. And then PSQL -H localhost 5454. So I think I'm going to have to do port mapping here. This is going to run from the client. So I have a couple options. One, if I include this right here, it should, if I run inside the container, it will work. Otherwise, I'm going to have to do port mapping again. So I'm going to add the port mapping back in, P5454, which is from, so I'm going to change this 5455. And then I'll modify this command. And the user will be Postgres, the database is going to be books. Okay, so that should be the right command. And now I'm going to rerun the container. Set up that SH. All right, and then I'll paste this command in. 5455.
You just need a space after your port mapping.
Oh, thank you. I wonder, yeah. Oh, it just didn't run. Thank you. All right, so I'll run this again. Okay, so I have another error. So I get a conflict because I gave it the same name here. It's not going to work. So you could change the name here, or you could stop the other container. So I'm just going to change the name here. Okay, so I do Docker PS. I can make sure that this is running. So DB2 is the one that I have running right now. So I'm going to execute this. Okay. And then I get this result. All right. Are there any questions about that? So the basic process is going to be you start with requirements, and then you come up with a model which you diagram out in one way or another. You can do it by hand or do it on a whiteboard or do it using some tool. And once you have that, then you're gonna create some kind of local environment. And you can use a tool like this if you want to, or you can just run the commands on PSQL. Make sure everything works locally. Once it works locally, follow the model of the cars DB basically, or the one of these others which does the same thing. You're gonna follow the pattern. You'll put your SQL commands in that SQL, and then you can run it. You make sure that it works, and then you can run some test queries.
For the purpose of the assessment, should we push our image in a state where whoever pulls it can just start entering some queries in, or should we have those queries run automatically as soon as they run the container?
Yeah, that's a good question. I mean, either one would be fine, but as a default, I think you can just do something like this, and then as long as you have the query file here, then I or whoever's creating it can just run it. And then yeah, so I didn't show pushing up the image, but you would also want to push it up to Docker Hub, so I can see Docker images. And here's this one. So once I'm sure that everything is working, blah blah blah, I want to push it up to Docker Hub. This is like the final thing that you will do. I can do Docker push. So first I'm gonna have to rename this because this is just called DB. So I'm gonna need to add my Docker username to this. So I could do Docker tag, and then books DB will now be my username. So Chad Mowbray / books DB, or whatever you want to call it. If you want to have different versions, you could also add a tag here. So I'll do 1.0. And if I do Docker images, you should see that now I have this, which is associated with my username. So I'll be able to push it up to Docker Hub. I'll have permission to do that. So now I can do Docker push. And I'll give it a version number 1.0. And once this is pushed up, any one of you should be able to pull this down, Docker pull blah 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 blah, and then you should be able to run it. And it should have all the tables there. It should have all of the rows inserted. So you should be able to just immediately start writing queries. Okay, so there's a lot of steps, and yeah, depending on your strengths or inclinations, the easy part might just be actually creating the database and everything, and the hard part is making it all work together. All right, stop the recording.